Hello and welcome. I'm so glad you are here today. You are about to start a very exciting journey. This journey will take you into the world of algebra. Maybe you have heard that word before. Perhaps it sounds a little bit scary or complicated, but I am here to show you a different side of algebra. I want to show you that it can be simple. I want to show you that it can be fun. We are going to take this journey together, one small step at a time. There are no tests here and no grades to worry about. It is just you and me exploring some new ideas. Today is a fresh start. We are going to unlock the secrets of algebra together. You will see that it is not about memorizing strange rules. It is about learning to think in a new and powerful way. In the next hour, we will break down the big ideas of algebra into small, easy pieces. Imagine we are building something with blocks. We will start with the most basic block. We will look at it, understand it, and then we will add the next one. Are you ready to begin this adventure? I know you are. Let's take our very first step into the wonderful and powerful world of algebra. So, what is this thing called algebra? At its heart, algebra is a special kind of language. It is a language that uses both numbers and letters. These letters are not as scary as they might look. They are simply placeholders. They stand for numbers that we do not know yet. Think of them as mystery numbers. Algebra is the detective work we do to find out what those mystery numbers are. You can think of algebra as a tool for solving puzzles. Imagine a puzzle where a piece is missing. You know what the final picture should look like. You can use that information to figure out the shape and color of the missing piece. Algebra works in a very similar way. It gives us a framework to find missing information. Arithmetic is the math you probably know well. It is about calculations with numbers like 2 plus 3 equals 5. Algebra takes this one step further. It might give you a problem like x plus 3 equals 5. Here, x is the letter, the mystery number. Algebra gives you the rules and techniques to figure out that x must be 2. So, do not think of algebra as a completely new subject. It is just the next level of your math adventure. When you hear the word algebra, what comes to mind? For many of us, it might trigger stressful memories of classrooms, confusing letters, and abstract problems that seem to have no connection to the real world. But what if I told you that you're already an algebra expert? In fact, you probably use it every single day, in dozens of small ways, without even realizing it. It's a natural part of how our brains solve problems. Let's start with a simple, everyday scenario. Imagine you're at your favorite coffee shop, ready for a morning boost. You've got a $10 bill in your hand, and you decide to buy a coffee that costs $3. As you hand over the money, your brain instantly starts working on a question. How much change should you get back? Now, you almost certainly don't write down an equation. Your mind just does it. You think, $10 minus the $3 for the coffee leaves $7. You've solved the problem in a split second. But let's pause and look at what your brain actually did. It understood a fundamental relationship. The money you started with is equal to the cost of the coffee, the change you receive. This is the heart of algebra, using what you know to figure out what you don't know. In algebra, we call that unknown amount a variable. It sounds technical, but it's just a placeholder, a mystery number we need to find. We often use a letter like x, or in this case, let's use C for change. So the situation can be described with a simple but powerful equation. 3 plus c equals 10. To solve for our mystery number c, your brain intuitively isolates it. It knows that to find the change, you have to take the total amount of $10 and subtract the $3 you spent. In algebraic terms, we subtract 3 from both sides of the equation. This keeps it balanced. 10 minus 3 is 7. So, c equals 7. You just did algebra. Let's try another common scenario. You're planning a fun road trip with friends. You've picked a destination that's 200 miles away. Now, you need to think about logistics, specifically gas. You know your car is pretty efficient and gets about 20 miles for every gallon of gas. The question is, how many gallons will you need to complete the entire 200-mile journey? Once again, you're faced with an unknown value you need to solve for. Your brain starts looking for the relationship between distance, efficiency, and the amount of fuel. You know that for every gallon, you can travel 20 miles. The term miles gallon is a rate, and that word per is often a clue that we're dealing with multiplication or division. We can set up a pattern. 1 gallon gets you 20 miles, 2 gallons gets you 40, and so on. So the number of gallons, let's call it G, multiplied by 20, must equal our total distance of 200. Our equation is 20 times G equals 200. To find G, you can ask, what number multiplied by 20 gives me 200? Or you can work backward with division. 200 miles divided by 20 miles per gallon tells you that you need 10 gallons of gas. And just like that, you're a natural algebra problem solver. We could even take it a step further. If gas costs $4 per gallon, how much will the fuel for the trip cost? You'd solve another algebraic problem. 10 gallons times $4 equals $40. Thinking of algebra as a superpower might sound a bit silly, but in many ways it truly is. It's not the power of flight, but the power of sight. The ability to see the hidden patterns and structures that connect everything in the world. It gives you the power to model a situation, predict outcomes, and make logical decisions. It helps you think more clearly and logically, especially when faced with confusing choices. For example, imagine you're comparing two different phone plans. Plan A costs a flat fee of $20 per month, plus $2 for every gigabyte of data you use. Plan B is simpler, a $40 monthly fee for unlimited data. Which one is the better deal? The answer is, it depends on your usage. Algebra gives you the power of clarity here. We can represent each plan with an equation, using D for the gigabytes of data. The cost for Plan A is 20 plus 2 times D. The cost for Plan B is just 40. To find out where the value proposition shifts, we can ask, at what point do they cost the same? We set the equations equal to each other, 20 plus 2 days equals sine 40. Now we solve for D. We subtract 20 from both sides, which gives us 2 days equals sine 20. Then we divide both sides by 2, and we find that D equals sine 10. This is the break-even point. It means if you use exactly 10 gigabytes of data, both plans cost the same. If you use less than 10, Plan A is cheaper. If you use more, Plan B saves you money. Algebra didn't just give you a number, it gave you a clear rule to make the best financial decision for your specific needs. This power of clarity and modeling is why algebra is absolutely essential in so many of the best and highest-paying jobs. An engineer uses it to calculate the load a bridge can bear. A computer programmer uses algebraic logic to create the apps on your phone. A data scientist uses it to find meaningful trends in massive amounts of information. Learning algebra opens doors to a huge number of exciting and rewarding career paths. But beyond your career or daily errands, the most important part of this superpower is what it does for your mind. Learning and practicing algebra is a workout for your brain. Every time you structure a problem, isolate a variable, and find a solution, you are strengthening the neural pathways responsible for logical reasoning and critical thinking. It's like taking your brain to the gym. This training doesn't just make you better at math, it makes you a sharper, more capable, and more confident thinker in all areas of your life. The biggest leap in algebra, the thing that can seem strange at first, is the use of letters. These letters are called variables. The word variable just means that its value can vary or change. We are moving from a world of only fixed numbers to a world that includes changing or unknown numbers. Why add letters to math? It is because letters allow us to be much more powerful and flexible. They let us write general rules. Think of these letters as placeholders. When we write an equation like x plus 7 equals 10, the x is just an empty box. The goal of algebra is to figure out what number goes in that box. Once we have our variables, we can start combining them with numbers. When we do this, we create something called an algebraic expression. An expression is a mathematical phrase. An equation like x plus 5 equals 12 makes a statement. It says the left expression equals the right expression. An equation is a statement of balance. It tells you that the thing on the left of the equal sign has the exact same value as the thing on the right. The equal sign is a promise. It is a promise of perfect balance. This promise of balance is the foundation for the single most important rule in all of algebra. This rule is often called the golden rule of algebra. It states, whatever you do to one side, you must do the exact same thing to the other side. This keeps the equation true. This visual of a balance scale is one of the most useful tools for understanding how to solve equations. The goal is to get the variable all by itself on one side. This is called isolating the variable. Welcome back, algebra adventurers. You've learned about variables and the golden rule of keeping equations balanced. Now you are officially ready to put those concepts into action and solve your first algebra equations. Think of each one as a unique puzzle, where your mission is to find the value of the hidden number. Let's start with a classic addition puzzle. A plus 8 equals 20. Our goal here is simple: to figure out what number A represents to make this statement true. We need to get A all by itself on one side of the equals sign. This process is called isolating the variable. To isolate A, we need to clear away anything that's on the same side of the equation with it. Right now, that plus 8 is standing in our way. So how do we get rid of it? We use its opposite. In mathematics, we call this the inverse operation. The opposite of adding 8 is, you guessed it, subtracting 8. So our strategy is to subtract 8 from the left side of the equation. But remember the golden rule of algebra. Whatever you do to one side, you must do to the other to keep it balanced. So we'll subtract 8 from the right side as well. Perfect. On the left side, we have A plus 8 minus 8. The plus 8 and minus 8 are a perfect pair of opposites. They cancel each other out completely, leaving us with just A. That's exactly what we wanted. Now let's look at the right side. We have 20 minus 8, which simplifies to 12. And just like that, our new balanced equation is A equals 12. We've solved the puzzle. A great habit to build is checking your work. Let's plug our answer 12 back into the original equation in place of A. Does 12 plus 8 equal 20? Yes, it does. 20 equals 20. Our solution is correct. Now let's try a subtraction equation. Imagine you had some money, spent $3, and now you have $11 left. That scenario can be written as B minus 3 equals 11. The principle is exactly the same. To isolate B, we need to deal with that minus 3. The inverse operation of subtracting 3 is adding 3, so we'll add 3 to the left side. And to keep our scales balanced, we must also add 3 to the right side. On the left, minus 3 and plus 3 cancel out, leaving just B. On the right, 11 plus 3 equals 14. So B equals 14. You started with $14. See? You've been doing algebra your whole life without even knowing it. You've mastered addition and subtraction puzzles. You understand the core concepts of inverse operations and keeping things balanced. Now it's time to expand our skills and add 2 more powerful tools to our algebraic toolbox. We are going to tackle equations that involve multiplication and division. Don't worry, the rules of the game haven't changed one bit. Let's look at our first multiplication equation. It might look something like this: 4x equals 20. A quick but important note on notation. When you see a number directly next to a variable like this, it always implies multiplication. So, 4x is just a shorthand way of writing 4 times x. Our goal is the same as always. Get x by itself. What's standing in our way this time? The 4 that's being multiplied by x. The inverse of multiplying by 4 is, of course, dividing by 4. So, we'll divide the left side by 4. To keep the equation balanced, we must also divide the right side by 4. On the left, 4 divided by 4 is 1, leaving us with just 1x, or simply x. On the right, 20 divided by 4 is 5. Solution found, x is 5. Let's do a quick check. Is 4 times 5 equal to 20? Yes. Our answer is solid. Now for our final type of one-step equation, division. In algebra, you will often see division written as a fraction. So an equation like y divided by 5 equals 2 will usually be written as y over 5 equals 2. It might look a little different, but it means the exact same thing. Our variable y is being divided by 5. To isolate it, we need to perform the inverse operation, which is multiplying by 5. So we will multiply the left side by 5. And of course, we must also multiply the right side by 5 to maintain balance. On the left, multiplying by 5 and dividing by 5 are opposites, so they cancel each other out, leaving just y. On the right side, 2 times 5 gives us 10. Our new equation and our solution is y equals 10. Let's check it. Is 10 divided by 5 equal to 2? Yes, it is. You've now solved all 4 basic types of one-step equations. But what happens when equations have more than one step? For example, what if you have both multiplication and addition? To solve more complex problems, mathematicians needed a clear set of rules so that everyone gets the same answer. This is called the order of operations. You might know it by the handy acronym PEMDAS. It stands for parentheses, exponents, multiplication and division done from left to right, and addition and subtraction, also done from left to right. This is the order you follow when you're simplifying an expression. Now here is the key insight for solving equations. When we solve an equation, we are not simplifying it, we are trying to it. We're unwrapping a present, not wrapping it up. This means we need to undo these operations in the reverse order of PEMDAS. So, when you look at an equation, you'll first undo any addition or subtraction. Then you'll undo any multiplication or division, and so on. You work your way up the PEMDAS ladder from the bottom. Let's solve our first two-step equation together, step by step. Our equation is 2x plus 3 equals 11. Okay, let's put on our reverse PEMDAS glasses. The first thing we look for is any addition or subtraction that we can undo. We see a plus 3. To undo it, we subtract 3 from both sides. On the left, the plus 3 and minus 3 cancel out. On the right, 11 minus 3 is 8. This leaves us with a new, simpler equation. 2x equals 8. Look at that. We've turned a two-step problem into a one-step problem we already know how to solve. Now we move to the next step in reverse PEMDAS, undoing multiplication or division. We have 2 times x, so we undo it by dividing both sides by 2. On the left, the 2's cancel, leaving our isolated variable, x. On the right, 8 divided by 2 is 4. And there is our answer, x equals 4. Let's do a final check with the original equation. 2 times our answer of 4 is 8, and 8 plus 3 is 11. It works! You have successfully solved your first two-step equation. So far, we've been working in the abstract world of x and y. But the true power of algebra isn't just solving puzzles on a page. It's about understanding the world around you. Think of algebra as a secret language that describes everything from the trajectory of a basketball to the growth of your savings account. It's a tool for making smart decisions and predicting outcomes. Now, it is time to take these amazing new skills and apply them. This is where algebra truly comes to life, transforming from abstract rules into a practical guide for everyday challenges. Let's start with a classic real-world problem. Imagine this. You've been dreaming of a new bicycle. It's sleek, it's fast, and it costs $200. You check your piggy bank and find you've already got a solid start with $60 saved. To get there faster, you make a plan. You'll save an additional $20 from your allowance or part-time job each and every week. The big question is, how many weeks will it take to save up enough to finally buy that bike? This is a perfect opportunity to build an algebraic equation. First, we need to identify our unknown. What are we trying to find out? The number of weeks, so let's assign a variable to represent that. We'll use W for weeks. Now, let's translate the story into math. Your total savings will be the $60 you already have, the money you save each week. Since you save $20, we can represent that as 20 times W, or 20 WE. So, your total savings after W weeks will be 60 plus 20 W. We want this total to equal the cost of the bicycle, which is $200. And just like that, we can write our full equation. 60 plus 20W equals 200. Now we just need to solve for W. Remember our goal, to isolate the variable. The W is currently tied up in multiplication with 20 and addition with 60. We'll undo the addition first. To get rid of that plus 60, we do the inverse operation. Subtract 60 from both sides of the equation to keep it balanced. 200 minus 60 is 140. Our new simpler equation is 20W equals 140. Now to free W from the multiplication, we do the inverse of multiplying by 20. We divide both sides by 20. 140 divided by 20 is 7. So W equals 7. It will take you exactly 7 weeks to save up for your new bike. And we can even double-check our answer. If we plug 7 back in for W in our original equation, we get 60 plus 20 times 7. That's 60 plus 140, which equals 200. It's a perfect match. That was a great warm-up. But what happens when the mystery variable, our x, appears on sides of the equal sign? This looks more complicated, but the principle is the same. Let's imagine a scenario. You and your friend are collecting rare trading cards. You start with a collection of 2 cards and manage to get 5 new cards each week. Your friend started with a bigger collection of 10 cards, but they only get 3 new cards each week. When will you both have the exact same number of cards? Let's use x for the number of weeks. Your collection can be represented by 5x plus 2. Your friend's collection is 3x plus 10. To find out when they're equal, we set them equal to each other. 5x plus 2 equals 3x plus 10. Our first step is to gather all the variable terms on one side. It's often easiest to move the smaller term to avoid negative numbers. So let's subtract 3x from both sides. On the left, 5x minus 3x leaves us with 2x. On the right, the 3x is eliminated. Our new equation is 2x plus 2 equals 10. Now it looks just like our bicycle problem. We subtract 2 from both sides, leaving us with 2x equals 8. Finally, we divide by 2, and we find that x equals 4. In 4 weeks, you and your friend will have the same number of cards, and this brings us to one of the most powerful habits you can build as a problem solver, the art of checking your work. It means taking your solution, in this case, x equals 4, and plugging it back into the equation to see if it makes a true statement. It's your built-in quality control. Let's try it. For your collection, it's 5 times 4 plus 2. That's 20 plus 2, which is 22. For your friend's collection, it's 3 times 4 plus 10. That's 12 plus 10, which is also 22. Since 22 equals 22, our solution is correct. This step is your safety net. It catches small mistakes before they become big problems and gives you total confidence in your answer. All right, now it's your turn to be the algebra hero. I'm going to give you a problem, and I want you to pause the video, grab a piece of paper, and solve it yourself. Ready? Here's the scenario. You're in charge of planning a school dance. The DJ costs a flat fee of $100, and tickets cost $5 each. Your goal is to raise a total of $500 for a school charity. How many tickets do you need to sell? The equation is 100 plus 5t equals 500, where t is the number of tickets. Okay, hit that pause button now and give it a shot. Welcome back. Did you get an answer? Let's walk through it together. The equation is 100 plus 5t equals 500. First, we isolate the variable term by subtracting 100 from both sides. That leaves us with 5t equals 400. Now, we just need to divide both sides by 5. 400 divided by 5 is 80. So, t equals 80. You need to sell 80 tickets to reach your goal. How did you do? Whether you got it right or not, the most important thing is that you tried. And with that, we have arrived at the end of our journey together. Take a moment to look back and appreciate the incredible distance you've traveled. You started by learning about variables as mysterious unknowns. You learned to speak the language of expressions and equations. You mastered the art of balancing them, using inverse operations to isolate the variable and find the solution. You've tackled word problems and even equations with variables on both sides. But perhaps the most important thing you have gained from this journey is not a specific skill, but a new way of thinking, a mathematical mindset. This is the ability to look at a complex, messy problem and not feel intimidated, but instead feel curious. It's the confidence to break it down into smaller, manageable parts, to apply logic and structure, and to work your way systematically toward a solution. This is a superpower that you can apply to every area of your life. As you continue on this path, I want you to reframe your relationship with mistakes. It's easy to see a wrong answer as a failure, but that's not what it is. From this day forward, I want you to see mistakes as your friends, as helpful guides. Think of it like this. A mistake is a signpost that points directly to a gap in your understanding. It's not a wall. It's a map showing you exactly where to focus your attention. Mistakes aren't the end of the road. They are the essential, unavoidable stepping stones on the path to mastery. You have laid a powerful foundation today. The world of mathematics and all the fields it unlocks, science, technology, engineering, finance, is now open to you in a new way. This isn't the end of your learning. It's the grand beginning. Go forth with confidence in your new skills and curiosity about the problems you can now solve. Your adventure is just getting started.